Alright guys, this is our 12th and final lesson for Unit 10. Your other assignment for this week is just going to be to do the take-home test and submit your answers that way. And just so you guys know, I'm not going to be checking notebooks anymore. Just kind of a little bit more work than it's worth, honestly, when we're doing this virtual learning thing. I would still, of course, encourage you guys, if you are going to be moving on into another math course next year, and if you find that you're somebody who really likes to have notes, I would encourage you to still take notes and still keep them in your binder and still keep them organized. Once again, remember, I'm not a textbook guy. I'm not using a textbook, so these notes are your book. These are the way you're going to remember things. So even though I'm not grading you on it, I would encourage you guys to consider still taking notes. Okay. But anyway, that being said, we'll go ahead and get started. So today we're going to learn how to solve trigonometric equations when the output values are not the special values on our unit circle. So let me give you guys an example that we're familiar with already. We learned how to solve problems like this before we left for our spring break. Okay. Now the reason that we can solve that is because the output value is a special value that is on our unit circle. We just have to remember that sine is the y value, right? So we're basically just asking ourselves, where is the y coordinate equal to a half? And all we would have to do is look at our unit circle and we would see the answers here and here. And we would know that the angles at those points are 30 degrees and 150 degrees, and those are our answers for the theta that we don't know of. So the reason that we're able to solve that is because the output that I gave you is a special number that's on the unit circle. But this is saying when y equals a half, right? But I mean, y can also equal something weird like 0.1, can't it? And that would be like more like down here. What angle would that be when the height of the coordinate is 0.1? Well, that's what we're going to learn about today. Okay, so how can we find those angles? Well, before we begin, I want to talk to you guys about the symmetry that is in the unit circle, because that's going to be really helpful for what we're doing. Now, the short answer to the question, how are we going to solve these types of problems today? Well, the answer is we're going to use our calculator. But the problem is the calculator is only going to give you one answer, but I'm going to want you guys to find two answers on an interval from 0 to 360. So first of all, we're going to start by looking at the symmetry of the unit circle. So we're going to start by reviewing a couple of things here. First of all, I hope you guys remember that cosine of theta is x. Okay, so for instance, cosine of 30 degrees is square root of 3 over 2. But I want you guys to find look around your unit circle, where else is there an x value that has a square root of 3 over 2? Where else is that located? Give you guys a chance to look around there. I don't know if you guys noticed, but it's right here. Those 2 points where we have a 330-degree angle and a 30-degree angle, they both have the same x coordinate. They're both radical 3 over 2. So they match. Let's do 45 degrees. What is the cosine of 45 degrees? In other words, what's the x value for that? Well, it's radical 2 over 2. Look around on your unit circle and see where else you can find an x value that is a positive radical 2 over 2. Right there, isn't it? Directly below it, right across from that y-axis. So let's do 60 degrees. What's cosine of 60 degrees? Cosine of 60 degrees is a half. Now you guys can probably find it pretty quickly and easily because you're starting to see a pattern. The other one that matches that is right here below it, directly across the y-axis. So all x values are the same directly below each other. There you guys have it. So there's definitely a symmetry going on here. And we're going to use that symmetry to be solving our questions today. So let me get out of here really quick. Move on to our next slide. So let's go ahead and do an example. I'm going to do 2 examples, and then I'm going to let you guys try a student practice. Example 1. Now here's how the directions are going to be looking for this. We're going to say find theta such that theta is between 0 degrees and 360 degrees. You'll notice I put an equal sign for the 0 but not for the 360. 0 and 360 are coterminal angles, so we don't really need to have both of them, but I definitely want to have both those endpoints. So we're going to give any values of theta that are good solutions so long as they're between 0 and 360. And here's my first question to you guys. Cosine of theta is equal to, let's say something weird like 0.72. So that's kind of a strange number there, right? It's not one of our special numbers on our unit circle, but we do know that cosine is the x value, right? So basically, we want to know where is the x coordinate equal to about 0.72. Well, this strategy here is not going to be too terribly helpful to us at the moment. What we're going to do instead is we're going to use another strategy that we learned before we went on our little spring break, which is we want to get theta by itself by doing the opposite of cosine. So what we do is we're going to arc cosine both sides. So here these cancel, and now I'm left with this, right? And this is where we have to get at our calculators to figure out the rest. Okay. Just a minute. Let me pull up my calculator here real quick. So how do we do this on our calculator? Arc cosine of 0.72. So the first thing I'm going to do is 0.72. I'm going to find arc cosine, which you guys remember you push second, and then cosine with a little -1. You want to make sure that your calculator is set to degrees and not radians, otherwise you're going to be getting wrong answers. But as you guys can see here, I got 43.94, blah, blah, blah. And for today, I'm just going to be rounding everything to the nearest degree. So instead of saying this is 43.945, blah, 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 I'm just going to say, okay, 43.9, that bumps us up to about 44 degrees, okay? Slideshow here real quick. All right, so we have theta is equal to 44 degrees at that particular x value, okay? Now, that's only half of the work, and the calculator does most of it for you, okay? So the question was, for what value of theta does cosine equal 0.72? And we want to find as many answers as we can on the interval from 0 to 360. Now, usually there's going to be 2 answers, and I just found one of those answers. And the calculator did it for me, okay? But we need to find another answer, because there is another one. Let's draw our unit circle. Now, the first thing I would encourage you guys to do is go ahead and draw a line where you think 44 degrees would be at. Where would the 44 degree mark be at on our unit circle? Well, hopefully you guys know 45 is right in the middle, right? So basically we're going to have a line that's right in the middle because 45 and 44 are really close to each other. So we have a point that's like right about here, and that's about a 44 degree angle, right? And we know that the cosine value at that point, the x value, is 0.72. We don't really care about the y, so I'll just put a question mark there, but there you have it. Now, If I have an x value that's 0.72 right here, where would I have another x value that is 0.72? Well, it would be directly below it, right about here. Remember how we talked about how all the cosine values, whatever you have here, the one directly below it across the y-axis will be exactly the same. So at that point down there, we're going to have 0.72 again for another x value. But we don't know what that angle is, do we? And that's what we need to find. We want to find out what the angle is. So, well, we know this. We know that this way is positive 44, so guess what this way is? It's negative 44. So, how can I figure out what it is, though? Because negative 44 is not going to be my answer because we want answers that are between 0 and 360. So what I need to do then is I need to find a coterminal angle for negative 44. Okay, so negative 44 was my answer. And hopefully you guys remember how to find a coterminal angle. You're just going to add 360 to it to make it a positive number. So I'm going to use my calculator here. 360 plus a negative 44 gives me 316 degrees. So this angle down here is 316 degrees. So there are two cosine values that give us 0.72, or two angles that give us a cosine of 0.72. They are 44 and 316. So let me go through the process with you guys again really quick before I do my next example. Okay, so step one, just use the calculator to find your first answer. Do arc cosine. That's easy enough. But the next one is where it gets a little bit tricky. You have to find this number on the unit circle. Then you have to find where that would be at directly below it. And basically just add 360 degrees to the negative version of that number. You get that. So there you have it. There's your two answers. And once again, you guys could get out your calculators here and you could totally check your work if you wanted to, just to make sure that you're right. So let me bring up my calculator and let me do out of the way. Let's see, clear. So let's do 44 cosine. So cosine of 44 degrees is 0.72 about, right? And we could also do, what was the other answer? We got 316. 316 cosine is also 0.72. So there you have it. You check your work by just plugging in the answers that you got into the original equation and seeing if they give you the right answer. They should give you about 0.72. So let's do another one. How about this? Let's say I have cosine of theta is equal to negative 0.95. Negative 0.95. Okay, so step one is we're going to arc cosine both sides. So if we arc cosine this side, we'll just be left with theta because the cosine cancels. And if we arc cosine this other side, we will get 0.5 inside there. And then from there, we're just going to use our calculator. So once again, you're just going to find the arc cosine of negative 0.95 on your calculator. Punch it into mine now. And I'm getting 162 degrees. Remember, I'm going to be rounding it up to the nearest degree. So there's step one. Just use your calculator to find the first answer. Now the next part gets a little bit tricky, so I'm going to pause and go a little bit slowly through this one and see if you guys can do each step as we go here. So first of all, what I want you guys to do is I'd like you to just see if you can on your own, locate where that would be at. Draw your line. $162 would be approximately right about here, okay? And so we know that the x value at that point is about negative 0.95. And we do not know the y value, but that's okay because we don't care about the y value right now. Now here's the next part I want you guys to do is I'd like you to find another place on this unit circle where you would have negative 0.95 for the x value. Where would it be located? So what we talked about is that this point, if you just reflect it straight down to the opposite side across the x-axis there, you will also have another place where the cosine value is negative 0.95. And that angle will be the same thing as the one on the top. The only difference is going to be the negative version of that angle. So it's negative 162 degrees. It's completely symmetrical. Okay? So here's the next thing I want you guys to do. Yes, we have our two answers. We have two answers now, I should say. We have 162 and negative 162. But remember, I wanted answers that are between 0 and 360. I don't want answers that are negative. So I like this first one. 162 is a good answer that my calculator gave me. I do not like this one. How can I change that answer so that it's between 0 and 360? If you can do that. The way that you're going to do it is you're going to take that answer and you're going to find the positive coterminal angle for that angle by just adding 360 to it. So let me do that. Calculator, I'm getting 198 degrees, and so my other answer will be 198 degrees. Okay, so at this point, I'm going to give you guys some student practices, and what I would do is I would encourage you guys to pause the video, try them out, and then check your answers. Okay, so let me make up two examples for you. All right, so go ahead and see if you guys can find the two answers to these problems. I'll post the answers in a few seconds here, so pause the video now if you don't want to see. Okay, and there are your two answers. Now, here's a nice little shortcut for you, but I think that the way I showed you is important because the next few problems we're going to get to will be a little bit different, and so I don't want you to get too cozy with this. But for cosine, I want you guys to understand this. Anytime you're dealing with cosine, or side note, secant as well, anytime you're dealing with cosine or secant, the first answer you get from your calculator, well, if you just subtract that from 360, you're going to find the other answer. Okay, those two numbers add up to make 360. So you don't need to be drawing pictures and stuff technically. However, that is a very good skill. That's how you get to this shortcut. And you're going to find that when we get to things like sine and tangent and all that, that little trick isn't going to work anymore. So be wary of using shortcuts. But that will work for sine and cosine and secant. All right, let's go ahead and move on to another example here. Example 2, we're doing the same thing. I still want to find answers theta, where theta is between 0 and 360. That's not going to change all day to day. I'm just going to keep that the same every time. But what is going to be different is instead of dealing with cosine, I'm going to deal with secant. So let's say I have secant equals 3. Well, we learned how to solve problems with secant before, and the way that we dealt with it was we started by remembering that secant is the reciprocal of cosine. So I can just rewrite secant as 1 over cosine, first of all, because that's what secant is. Secant is the reciprocal of cosine. Then the next thing that we can do is we're going to flip both sides over. Okay, so if I flip 1 over cosine over, I get cosine theta. But I also have to flip 3 over. So think of that as 3 over 1. If I flip that over, it becomes 1/3. And so now, guess what? We just have another cosine problem to solve. So secant is really just a cosine problem in disguise. Okay. Let's go ahead and solve this now. So to find my first answer, I'm going to arc cosine 1/3. Right? Let me get my calculator out and do that real quick. And I'm getting 71 degrees. And remember, so I'll do it the long way, but you can also do it the short way if you want to. 71 degrees on the unit circle would be about here. And if the one that goes with it would match that answer of a positive 71 degrees would be the one directly below it at negative 71 degrees. Okay, so how do I transform the negative 71 into a positive? Between 0 and 360, I take 71 and I add 360 to it, and I've got my other answer. So that would be 289. There's our two answers. So from this point on, it's exactly the same as what we've been doing since the lesson started. But the difference for secant is, of course, that you have to do the reciprocal first on both sides. So let me throw a student practice at you guys with secant now. Let's say I gave you guys secant of theta equals negative 1.5. See what you guys get. Pause the video here to check your answer in a moment. And our two answers for that one would be 131 degrees and 220 degrees. All right. So we talked about how to deal with cosine and sine. We're going to switch gears here now. We're going to talk about sine. I think I said that wrong. We talked about cosine and secant, right? So now we're going to switch gears and we're going to talk about sine and cosecant. Now, let's review a little bit. First of all, you guys remember that cosine equals x, right? But sine is the y value. So let's begin here by finding our first one. How about what is sine of 30? Well, that's the y value when we're at 30 degrees, which is right here, right? So sine of 30 is a half. Now look on your unit circle. Where else is there a half? And I'll give you a hint. It's not this one. It's not directly below it because that's a negative. We want it to be a positive half. So where else does sine equal a half, a positive half? There it is. You guys see now, it's instead of going downwards to find the match, we go directly across to find the match. How about sine of 45? What's the y value when we're at 45 degrees? That's radical 2. And no surprises, the one that matches it is directly across from it. How about this one? Radical 3 over 2, radical 3 over 2. Why does this make sense? Well, all those points have the same height. They're both the same distance away from the x-axis, so they all have the same y value. And that pattern holds down here as well. These are the same, these are the same, and these are the same. So whereas cosine goes up and down to find the symmetrical matches, sine goes left and right to find the symmetrical matches. Okay. All right, so that being the case, we're ready for example 2 then. Let's go ahead and do, I'm sorry, not example 2, we're on example 3 now, aren't we? Change that color though real quick. So once again, we want to be finding all angles for theta. Find theta such that theta is between 0 and 360. In other words, where would it be located on our unit circle? All right, so let me make up a problem here. Let's say I have sine of theta equals, how about 0.3? Okay. Well, the first step is not going to be that mind-blowing. It's going to be a lot like the last one that we did. You're just going to do arc sine on both sides. Arc sine this side, arc sine the other side as well. These cancel, and so we have theta equals arc sine of 0.3. And once again, you're going to get your calculator out, and you're going to find the arc sine of 0.3. I'm getting 17 degrees. Okay. Now, let's see here. For this one, then the next thing we're going to do is it's still a lot like the last problem. We're going to find where this is at on the unit circle. 17 degrees would be like right about there, right? But this is where things are going to get a little bit different, okay? So since we're dealing with sine, this is a y value. So sine of 17 degrees is 0.3. So the y value here is 0.3. And what we talked about in the last slide was how the one that matches that is not directly below it, but instead directly across from it in the second quadrant there. So over here we have a y value of 0.3. And here's the tricky part with this. This angle right here is 17 degrees. So guess what? So is this one. That angle is also 17 degrees. So how are we going to figure out what angle it is over here, though? Because you got to remember, when you're doing a unit circle, the angle always starts from over here. So this one, the arrow stops here at 17 degrees. But if you want to find this spot, you actually have to go all the way over like this. So in other words, even though this little chunk that we're looking at is 17 degrees, what we really want to know is what's the angle that goes from here all the way over to here. Okay? And so now how are we going to do that? Well, it's going to be 180 minus 17 degrees. So instead of going, like, you guys know that a whole half circle is 180 degrees, right? So if I were to just subtract away this little piece over here, that would leave me with the angle I want. So 180 take away 17 is the trick for finding the matching sine value. And I'm getting 163 degrees. So the two theta values that will give us a sine value of 0.3 are 17 and 163. And once again, we can check our work on this. So let's do that. You don't have to check your work, but it helps make things make sense a little bit. So we said that sine of our answers, theta, should give us about 0.3. So what I'm going to do is, we had two answers. My two answers were 17 and 163, right? So I'm going to plug in those two answers and see if they actually work. So 17 sine 0.3. I wonder if I can move these at all. My way. Can't move my annotations. All right. But anyway, so 0.29 is what I get on my calculator, and that's basically 0.3. So we know that this is a good answer. Theta equals 17. Let's try another one here. Let's plug in the 163. 163. Sine, once again, 0.3, so we did it. Okay, so here, go back to our slide. And before I give you guys a student practice, I want to give you two more examples. Let's go ahead and do another one here. We'll call this B. We'll call the last one A. How about this one? Sine of theta is equal to negative 0.6. All right, so the first thing I'm going to do is we're going to arc sine 0.6, and that's a calculator exercise. Getting 37 degrees. The next thing we're going to do is we're going to draw our picture. We're going to find where does the angle equal 37 degrees. That would be right about here. At this point, I'll go a little slower for you, and I'll ask you guys to find where would the angle be that would match 37 degrees for a sine value of, wait a minute, something's bogus here. Let me back up. Actually, I just realized I have a boo-boo. Backing up. Not punching the calculator right. I forgot to make it a negative. Let me try that again. Arc sine of negative 0.6. It's negative 37 degrees. Same answer, it's just negative. There we go. Now, that is a little bit more challenging. So I'm going to pause here now. I'm asking us to find that angle. Where would negative 37 degrees be located? All right. Well, hopefully, you guys know that we don't even like 37 degrees very much, right? I'm pretty sure some of you guys found it already. It's down here. However, you know that we want our answers to be between 0 and 360, right? So what we're going to do is we're going to take that negative 37 and we're going to add 360 to it. So that real quick, and I get 323. Okay, so there's one of my answers. So this is an interesting new turnout. The answer that my calculator gave me is the one that I have to add 360 to in order to find the actual one. It's 323 degrees, which would be about right here. Now the next thing I'm going to ask you guys to do is I'm going to ask you to find where would you draw an angle so it matches this. Now remember, this is sine. Sine has matching answers going left and right, not up and down. So see if you could find where the matching angle would go. Well, if you were to take this line and reflect it to the left, it would end up over here. And so the one that matches it would be right there. Okay. Now, we know that this is a 37-degree angle right here. And the reason it's 323 is because that's what it would be if you went all the way around the beginning. But we know that the little drop down there is a 37-degree angle, and so is this one. So now I'm going to give you guys an opportunity. You guys got to figure out what is this angle. This measurement right here is also 37 degrees. What is the angle starting from 0 and going all the way up to here? Well, hopefully you guys recognize that it's 37 plus 180. Now you guys might be confused. You said, Mr. Bailey, last time you said it was subtraction. Well, it was subtraction last time. But this time it's addition. And the reason it's addition is because we're going from here, that's 180, and then we have to go 37 more. So that's 180 plus 37. So what would that be? 217. And you guys are frustrated at that because you're thinking, man, I just wanted a nice trick. I wanted to always be minus 180, and it's not. That's not how it works. Cosine's nice. Cosine, you could always just add 360 to it or whatever and you get your answer, but sine is not as friendly. So sometimes you're going to add 180 to find the other one, and sometimes you're going to subtract, and it just kind of depends. And that's why the skill of drawing the picture is kind of important, so you know when to do that. All right? So let's do one more example before we have you guys do some student practices. This time, I'm going to do a cosecant. how about negative 1. All right. So what do you guys think I'm going to do first here with this cosecant theta? Hopefully you guys are thinking, oh yeah, cosecant is the reciprocal of sine, so I'm going to change that into 1 over sine really quick. And then what are we going to do? Well, we're going to do the reciprocal on both sides. So if I flip over my 1 over sine, I get sine theta. And if I flip this guy over, then I'm going to get, we'll think of that as over 1, right? 1 over negative 1.9. And then after that, we do arc sine on both sides. So let me get my calculator out and figure that one out. Arc sine of 1 divided by negative 1.9 is negative 32 degrees. Okay, but we don't like negative answers, right? So we're going to take that negative 32 and we're going to add 360 to it. So we get the positive coterminal version of that angle, which is 328 degrees. Okay. Now the next thing that we're going to do is I want you guys to find that angle on your unit circle. Draw a line where you think that would go. Be like right about here, right? And now remember, we're dealing with sine, which is y values. Where would the matching angle be for that one? That would give me the same y value of negative 1.9. Well, actually, that's not the y value, just so you know. That's the reciprocal of the y value. We don't know what the y value is, basically. All right, well, hopefully you guys know that the matching one would be the one directly over here across from it. Okay. Now, how do we find out what that is? So we know that this angle here is that negative 32 that we had, right? So this would also have to be 32, correct? So the question is, what is that angle? And hopefully you guys know that's going to be 180 plus 32, which is 212, I think. Yeah. So we have our two answers, 328 and 212. All right. So I'll put up some student practices for you guys. Okay. Go ahead and solve those out. I'll take seconds here and then put the answers up. Pause the video if you don't want to see the answers. And there you guys go. All right. So as you guys know, I'm only allowed to give you guys 2 hours worth of work a week. So, but there's more to this lesson I wanted to do. And so what I'm going to do is I'll just count it as some extra credit for you guys to do. I'll just include them as extra credit homework questions. You don't have to watch the rest of this video from here on out. You can stop and just do the normal part of the homework if you want to. But if you want to get the extra credit, watch the rest of the video and you can do the other problem. Okay. All right, let's move on to the last part of our lesson here. We're going to deal with, so we've talked about sine and cosecant. We've talked about secant and cosine. The last two that we haven't talked about yet is tangent and cotangent. Notice they come in pairs and they all behave a little bit differently. So in case you guys don't remember, let's review a little bit here first. Cosine, the x values match vertically, whereas the y values, sine, match horizontally. But when we're talking about tangent, it matches diagonally. It's kind of a weird thing. So for instance, what is tangent of 30 degrees? Tangent of 30 degrees is radical 3 over 3. The other place on our unit circle that matches that is right here. It's diagonal from each other. The same thing applies for 1, right? So tangent of 45 is 1. Diagonal from that, we have another one where tangent equals 1, and that's 225. Now, here's the cool thing about the tangent ones. Since they're diagonal, always straight across a straight line, they're always 180 degrees away from each other. So whatever one of your angles is, 30 degrees, if you just add 180 to that, you get the other angle that will have the same tangent value. Okay? So that's how that's going to work. Let's go ahead and do some tangent problems here. Example 3. Once again, we're going to stick between 0 and 360. Let's say I had tangent of theta is equal to 2.5. Of course, we're going to arctan both sides. Okay? So, we have arctangent of 2.5 is 68 degrees. So we're going to find where that's located on our unit circle. Probably be somewhere right about up here. So a 68 degree angle would have a tangent value of 2.5. Tangent value. Well, the one that matches that will be diagonal from that. So right about down here. That will also have a tangent value of 2.5. But what is that angle? Well, that angle is exactly 180 degrees away from our last angle, 68. So all we have to do is take our last answer, 68, and add 180 to it. Now don't get too cozy with that. Sometimes you're going to add 180, sometimes you do something else, but let's see here. 68 plus 180 is 248. So I can't emphasize enough the importance of being able to visualize these things and draw a picture so that you can do the math right. There's really just not nice shortcuts necessarily. There are, but you kind of, the way you get to know them is by doing this visual imagery in your head. Let's do another example. How about tangents of negative 1.2? So start by doing arctan, right? Getting negative 50 degrees. We don't like negative answers though, right? So I'm going to add 360 to that. And I end up with 310. So there's my first answer, and I want to find where that's located on the unit circle once again. 310 degrees. That's going to be like somewhere like right about here, I believe. That's a 310 degree angle right about there. Get rid of the angle line that I drew. Now, where's the one that matches it? Well, it's diagonal to it, so it's going to be over here. So if this is 310, what's this angle going to be up here? Well, you can't add 180 to it. If you add 180 to it, guess what you end up with? Let's see. You're going to end up with 490, and we don't want answers that are bigger than 360, right? So how are we going to find out that angle if I can't add 180 to it? Well, we could go the other way. How about we subtract 180 from it? Go backwards. And that gives us 130 degrees. So we're not going to add it, we're going to subtract it in this case, and we're going to get 130. Okay, so our two answers then are 310 and 130 degrees. So sometimes you're going to add 180, sometimes you're going to subtract it. It just depends on where you're at. Okay, let's do one more example. How about cotangent? We haven't looked at a cotangent example yet. Let's say cotangent equals 4. Well, not too surprising. When it comes to the weird trig ratios that are not actually on our calculator, we always change them into the reciprocal things, right? So the first thing I'm going to do is I'm going to change this to 1 over tangent. And then I'm going to flip it over. And then I'm going to arctangent. I get 14 degrees out of that. Our picture, 14 degrees is going to be pretty low. It's going to be right about there. So diagonal from that will be over here. What would that be? Well, if this is 14 degrees, I think I drew that diagonal really poorly. Let me back up a little bit. Probably be much more like that. So if this is 14 degrees, how can we find out what angle this is? Well, in this case, I think we can add 180 to it, right? So if it's too big, subtract 180 if it's too small. Well, if it's small enough, then just add 180 to it. So if I add 180 to that, I'm going to end up with 194 degrees would be the other answer. All right, so that does it. See you guys later, and next thing we'll be working on is our test.